Okay, everyone, welcome to the Web Track, the best track. We're the only track with a balloon, of course. So this is Mike. He's going to introduce himself properly, but he's going to be talking about offline applications or offline first applications, something that's probably quite important given the state of our internet on the African continent. So with that, Mike, off you go.
Awesome. Thank you very much for the introduction. I appreciate it. And by state of the internet on the African continent, you mean the state of the Wi-Fi at the conference venue, right? Okay, let's just make sure we're clear on that. So, hi, I'm Mike. Thank you. I think you'll agree that's a remarkable likeness of me. I'm a Google Web Developer Expert. Google Developer Expert in Web Technologies, which is basically like a merit badge for the sheer number of hours I've spent apologizing for JavaScript's idiosyncrasies. So, there's that. I work for a company called BBD Software Development. I work in the research and development team there, where we do stuff like training, consulting, and some industry-specific research and development. But I don't think I could explain to you succinctly on a day-to-day basis what it is that I do. But they still pay my salary, so I think it's working out. I'm also a co-organizer of the Josie.js meetup group. I love community, which is why I'm speaking here tonight, and I love JavaScript, and we combine those two things under this banner. Happens every month on the third or second last Thursday of the month, and some months those are even the same day. So if you're free, if you want to come take a look, and I've see a whole bunch of familiar faces, you should totally come and check it out. So I wish I could explain myself as this person when it comes to JavaScript. I mean, this is how I would like to see myself. But unfortunately, the reality is far more something like this. So you know what you're getting into with this talk. Okay, there's going to be a ton of JavaScript, and it's going to happen really quickly, and whatever happened to Pepe Silvia. So what are we here to talk about? We're here to talk about progressive web apps. Now, progressive web apps are actually a really, really big topic, right? And they're very laden with buzzwords. So we're not going to use the PWA buzzword very, very much. We're going to talk about a small part of it, and that's the network facet of progressive web apps and some of the design around it. We're also going to add a little bit of local flavor to it, because I feel like we've got some very particular context in Africa and in South Africa for progressive web apps. Now, where we're going to start off with is, I'm not sure if you're aware, but South Africans have a complicated relationship with time, okay? When we say the word now, we mean immediately, probably. There's a high likelihood. When we say the word now, we mean soon. It's probably going to happen soon, right? And when we say just now, we mean later or not at all, right? Sometimes we say just now, and we're just never going to get to it. And I think this puts us in the right frame of mind when it comes to dealing with the complicated relationship with the browser front end has with the network stack. Okay, so by virtue of a worked example, a salient work example, I was browsing specials at any resemblance to e-commerce sites, both real and fictitious, is purely coincidental. I was browsing Black Friday specials, as one does, and I found this Bluetooth toothbrush that I don't know what it does, I don't know how it works, but I can no longer live without it. Okay, I must have this in my life. So like the eager buyer that I am, I smash on that buy button as hard as I can, and then something happens. Nothing. Okay, but something has happened. Let's zoom in a little bit, right? I've got a spinning circle. This is what it looks like for me. I'm like, oh, okay, cool. The browser's busy doing something, right? It's going on the network stack. And then this happens. I'm like, ooh, okay. I thought I was on good internet connection, but it's all right. Don't panic yet. Everything's fine. And then this happens. And then that little piece of my soul starts dying. And I'm like, oh no. The dread builds. And then I know that this is the next step. It's invariably, and you're laughing because you've experienced it too. And by this point in time, I've decided that I need that Bluetooth toothbrush. My life is incomplete without it. I will wait. I will wait for however long it takes. And luckily, eventually I am rewarded with the page loading. It's just not the one that I was hoping it would be. Okay, so, and I'm not saying that this is a common occurrence, but it's a relatively common occurrence, right? We see stuff like this around the web the whole time, where experiences are brittle. So what are we going to talk about? The part that we're going to focus and really razor in on is this idea of network tolerance. And you might know the concept by a couple other words, right? You might know it as just connection resilience or partition tolerance if you want from the distributed systems world, or any kind of networky stuff. One of the buzzwords that gets thrown around quite a lot, particularly in a European and American context, is offline first design. Who's heard of this, right? Who's heard that word being said? Okay, a couple people. And when they say offline first, and they use the analogy of, they're busy browsing the web and, their subway goes through a tunnel for like 2.5 seconds, and they have intermittent connectivity, I think, man, I've got 150 megabytes of data that needs to last me to the end of the month, and it's still 2 weeks to go, right? That doesn't mean the same thing to you as it means to me. Anyway, but that's my rant aside. So how do we do this? How do we manage to treat offline as a first-class citizen? Well, the first thing we do is we communicate state well. And you saw that as a part of the worked example that we're too familiar with, right? We don't know what's happening. The browser, the app isn't telling us what's going on. We have to rely on our own sleuthing skills via the operating system. And that's not great. So in order for us to embrace these native aesthetics and native ideals, we need to communicate state and the behavior far more effectively. Now, the second part, and with any kind of big buzzword-driven technological movement, there's that one fulcrum technology that everything hinges around. And in our case, it's service worker. Now, the service worker that you may have heard of is basically a JavaScript worker that's got access to the networking stack. So you can think of it basically like a reverse proxy for your front end. Okay? And it's very powerful. It can't communicate directly with the main thread, but it can do some very, very exciting things from a network perspective, which is what we're going to dig into. It's got access to a whole bunch of really nice low-level primitives, and it's a well-designed API, but we are going to be using an abstraction layer, one of my favorite libraries, which is called Workbox. Now, Workbox gives us the ability to write routing, gives us pre-caching access, and stuff like abstracting off of the sync API for something called background sync, which we're going to leverage off of, and a whole bunch of other stuff. Now, background sync itself uses IndexedDB very, very heavily. And IndexedDB is one of the bits and pieces that we're going to use and have access to as a part of our service worker. Now, one of the nice affordances of service workers is that because they're relatively modern, we get a safe guarantee of a whole bunch of technologies that we have access to, one of them being IndexedDB. But now, if anybody's done any work with IndexedDB, you'll know that it is a challenged API that was designed by a very opinionated committee. Now, if this was the HTTP API, web API landscape inside the browser, then that would be IndexedDB. Okay, so it's not the best, but it's very, very effective. So we're going to be using an abstraction layer, a very simple abstraction layer on top of it. Okay. So I think that's enough of my blah blah for the moment. I'm going to do a whole bunch of live code, and it's going to come at you really quickly. So hang on for the ride. And as with any kind of live demo, right, we're all in this boat together. So I expect you to help me when things go wrong. Awesome. Okay, step one. So we have this very, very small application, which my team is very privileged to speak into community quite frequently, something that I'm very proud of. You've already seen a couple, and you might notice that we are meme-heavy presenters. So I built a little application that generates memes for my team. And I believe that there's a Lord of the Rings scene for every possible scenario. Jerry, sitting in the front here, is a 50-50 split between Star Wars and corgis, which you'll see later on. And Rory, who's not here today, unfortunately, is all about Ron Swanson. But if you'll know him, you know it's true. Okay, so this thing is great, and it lets us create memes and do whatever the thing we want that seems appropriate. But unfortunately, as soon as we go offline, or we have any kind of connectivity, it just doesn't behave itself really well, you know? Let's go online to show some more misbehaving. Let's reload that. Offline. And you'll see that it just doesn't recover very gracefully. So if there's that intermittent network connectivity, it basically sucks, and we have no clue as to whether it's online or offline or what's going on. The first thing we're going to do is we're going to work on some eventing. So luckily, the browser has access to the Events API, and we're not going to do a hell of a lot of React code, very, very little in this application, but there is this one lifecycle event that's really useful for us, which is when the whole application mounts inside our center. And in here, we're just going to add a couple event listeners. So it's on the window object, and we've got this ability to add an event listener that's going to listen for either offline or online events. And what that's basically going to do is that's going to call this method that's going to toggle either true or false. Okay? That method is then going to do a bunch of things. It's going to figure out if the value is changing and whether we need to show a toast. It's going to set a timeout so that we can hide the toast after 2 seconds, so 200 milliseconds. It's going to figure out what message it needs to show, and then it's going to set state, which is going to trigger the lifecycle events and the rendering of React. Okay? Then at the bottom here, we're just going to smash it right at the bottom of our page. And just have a simple toast that I've added already to this application, where we pass in the message and whether it should show or not. Okay. Now this is running, so if we reload the application, the first thing we can see is that when we go offline, the toast appears in and it says, hey, you've gone offline. And then when we go online, the toast appears and says, hey, we've gone online. There's a whole bunch more that you can do with this, but it just goes to show that it's not very hard to get started with communicating the state effectively. Now, that's about as far as we can go inside just the browser window. Or inside the React application itself. For everything else, we're going to have to leverage off of Service Worker. Now, I've already set up a Service Worker using Workbox that's very bare bones in here. The Workbox config, as you can see, it points at where my build directory is going to be. It says, well, these are the patterns that I need to look for to pre-cache into that application. And I swap these around. So this is the source service worker, where we're actually going to write our code, and this is the generated destination service worker, as well as inside that destination service worker, that is the variable that we're going to look for to smash all of the pre-caching bits and pieces into. Okay? Now how we use this is we've got the source service worker that has some bits and pieces. So firstly, it imports some stuff locally rather than via CDN. And that's because I didn't know if I could trust the conference Wi-Fi, something that turned out to be true. I regret not having imported Horse.js here, but hey. And then we've got some plumbing stuff that we have to set because we're not using a CDN to just convince Workbox's internals that get lazy loaded that it's getting stuff locally. And then we do this YOLO skip waiting, which is basically just going to shoehorn in the service worker. I'm going to cover some details a little bit later on for resources as to how to do this better, but it's expedient for the moment so we can brush straight past it. So what we need to do is we need to start off with something relatively boring, and that's to say all of our static JavaScript and CSS, we need to pre-cache, right? And all we're going to do is we're going to create this pre-cache manifest variable that Workbox is going to look for and smash all of those pieces into, and then just pre-cache and route that. Now, once we've done this, we can stop, rebuild. It builds a little bit faster than Angular for anyone who was at my DevConf demo. So that's less of an issue. And then we're going to start. Now, I've created the start SW npm package, which does a couple things. So firstly, sorry, it's at the bottom and there's no way for me. Wait, I can get it to the top. No, I can't. Can I do that? No, I can't. That wasn't thought through. Start SW. So it does a couple things. It copies the Workbox libraries locally, then it does an inject manifest, so it finds the pre-cache and it puts in all of the pre-cache bits and pieces, and then it starts up a local utility called HTTP server that's going to serve our application. So this thing sort of fakes running on a production app server. And that's because service workers really have no place at dev time. You only want to test them with prod builds. Okay. Now, when we start that up, it does a whole bunch of stuff pretty quickly, and we're going to go to localhost 8080 and see exactly the same application. Isn't that exciting? But if we go to our application panel, we can now see that there is a service worker that's installed and running. And if you look at our sw.js, we can see that there is all of the stuff that's been written into that array, which is basically the path of the file as well as a file hash so that we can version it. Okay, that's great. And if we take a look at the network panel, we can see that all of our static assets there are being delivered from the service worker. But before this thing can operate in an offline manner, we need to cache all of the rest of the stuff, right? Firstly, the JSON data that's coming back, and then some of the images. Now, how we're going to do that is we're going to do that off of runtime routing and lean off of Workbox to achieve this. So as a part of our runtime routing, we get a bunch of things. So we get to provide, well, we get access to this routing namespace with a register route method that requires 3 things on it. It requires either a fully qualified URL or a regex to identify a route uniquely, or identify a route. It requires a strategy, which is either cache first, network first, or stale while revalidate. And in this case, we're using cache first, which means if it hits it in the cache, it's not going to go into the network. We've got some config passing through, and we specify the HTTP verb. The only thing we're doing differently on this memes route that's going to get quite a lot of action is we're using stale while revalidate, which what that means is it's going to go and see if something's in the cache. If it's in the cache, return it, then still hit the network, and then off of the network, get that data and update the cache. So you're always just a 1 request behind having fresh data. Okay, so it's relatively useful for this example. Now that deals with, oh, and then the last one is, that looks a little bit differently, is just the thing that's going to look for our images. Okay? Now, in that scenario, we can restart this thing. Restarted, reload it, and I'm going to go to the application tab. Oopsie. Application tab, and we're going to take a look at the service worker installing. And you can see the skip waiting, installing and overwriting that service worker. To not tempt the demo gods, I'm just going to quickly double check at the bottom here. Yes, our code is there. It is the latest service worker. Sorry, that was the wrong command. Show application. And then we can navigate the site, but if we go offline, we can see that we can still navigate backwards and forwards, but we're not behaving very well when we get to stuff that we haven't accessed yet. And that's because this stuff is being cached as we access it. So if you look here, there we've only got data for Lord of the Rings and Star Wars, not the other 2, right? So we need to handle that confusing break in state, because we don't necessarily want to pre-cache our whole applications with data, right? That doesn't make any sense. All right, so how do we do that? Firstly, we go online. Before future Mike hates past Mike. Great. And then we're going to do some exception handling. So there are 2 ways to do exception handling. You can either do it on a route-by-route basis, or you can do it in a global context. And luckily for us, we're going to do both. Okay. So what we're going to do for the, and I'm going to move this down in a little bit, just before I forget and it breaks. What we're going to do is we're going to define our own custom strategy. And our own custom strategy is not very complicated. It's just an async function. And that function is going to take an object, and we just care about destructuring the event out of that object. And then we're going to do 2 things. We're either going to try and use whatever existing strategy we had, or if that fails, we're going to return some faked data. Now that's pretty easy. For the existing strategy, we're literally just going to use the stale while revalidate strategy that we were using below. And then on the error condition, we're going to do this. We're going to create a fake piece of meme data, including images that don't exist, and we're going to return a fake new response to make sure that the application keeps working. Okay. Now this image, I happen to know, doesn't exist. So we're going to also show, oh wait, before I go any further on, let's use that API strategy, otherwise everything is going to break. So that image doesn't exist. So what we're going to do is we're going to also use, oopsie, that's premature. 9. We're going to use global error handling. So what we can do is on our routing namespace, we can set a catch handler that'll deal with any route that fails. And we get that exact same event object through, and we get a whole bunch of metadata associated to it. So like the URL, the request itself, and in this case, the request destination. And the only one we really care about is image. I don't understand what generic caching JSON data really adds value. But you could put a 404 page in here if you needed. And for that, I'm going to match it to this facepalm JPEG that I snuck into the static assets. And if I don't match anything, I'm just going to return an error. So if we then go and rebuild, rerun, reload the application, okay, it is online, it is installed, and if we because we've still got our cache data, if we go offline and keep navigating, oh no, what did I do wrong? Oh no, things are about to get hairy. Okay, reload. Let me just make sure I'm using the right service worker. Okay, application, service worker, sw.js is the latest code there. Register root API strategy. No, it's not there. I think I forgot. Oh, Visual Studio Code, I forgot to save. I sincerely hope that's the worst of my demo fails for the rest of this presentation. Okay, so let's hope we get the latest service worker. All right, cool. We've got the catch event. That's great. That's great. Meet's back on the menu, boys. Okay, and then if we go to something where the image breaks, we just say, oh man, we can't find that meme. We're really sorry. And it works for the template stuff. It doesn't work for the template stuff because I haven't loaded any template data. Let's go online again and then move on. Wait. This is the first time really that we've got an offline application, right? You can keep using it. The only thing you can't do is you can't really create state. Now, as cool as it is to browse the memes that I've created offline, that's not very useful, right? Because we want to be able to either share stuff, and we need to be online to share stuff, or create new ones. So we're going to take the next step, and we're going to look at saving data offline. Online, if I can type. Hey, typing is hard. All right, so what we're going to do is we're going to use the background sync API. Now the background sync functionality, which is an abstraction of the sync API and something where it will basically queue and replay HTTP requests. Now there's two ways of using this. You can either use it as a plugin on an existing route, which seems very efficient, or you can trigger it manually. And obviously, I'm going to trigger it manually. So that's how you create a new queue, and I wish it was as simple as that, but it's unfortunately not. So we need to basically intercept the network stack, right? We need to catch all of those fetch requests and then replay them onwards. So we're going to add a listener onto any fetch event that comes through. Now the fetch event gets exactly that same event, and we're going to match any URL that matches memes and any request that's a post to memes to be able to catch it. Then what we're going to do is we're going to replay that request ourselves because we're taking responsibility for the network stack now. Okay? We're going to replay a clone of that request because if we read the body of the request, it's broken. So all of the new APIs are using an immutable-based design that needs to be copied. And then if that fails, we're going to queue a change using, again, a clone of that request. Now the queuing of the change is relatively straightforward in this sense. We're going to add that request to the background sync queue, and then we're going to return another empty faked response saying, it's cool, everything's all right, you can carry on without breaking. Now that's fine, and we'll save all of that data, but we're not surfacing any of it to the user, right? And we want to communicate our state very well. So what we're going to do for this, and I suppose the reason why we can't use the background sync stuff directly is because it's storing the whole HTTP request, which I'll show you in a minute. So it's not very usable to us. So we're going to steal something from event sourcing, and we're basically just going to create a usable copy of that data that we can surface. And that's going to be relatively straightforward by just going, clone that request, read it as JSON to the end, and then throw it away, get the meme data, annotate it as offline because we're keeping a transient copy of that data, and then use this IDB keyval abstraction layer on the confusing IndexedDB stuff, and then just smash it into the array of memes. Okay? Just keeping a local copy of it. Awesome. And then we can rebuild this, and we can take a look at something. So if we rebuild as part of the application, we're online, I hope. Yes, we're online. We get the latest stuff, and now we're going to open this app. Start with, oh no, please work. And then we're going to go offline. And we save it. So the first thing that we see is in here, and I'm going to drag the tiny handle all the way up, we see that there is this request, or the workbox logging, where it says request for blah has been added to background sync queue, okay, which is useful. And how that looks is as follows. Inside IndexedDB, if we refresh that and we go all the way down to workbox background sync, we will see that there's this queue that has some memes to be saved data in it. And inside here, you'll see that it is a full HTTP request, right, including the blob data and so on and so forth, which is not very usable to us, but we've saved a copy of it in this keyval store abstraction, which basically just has a list of all of the memes offline. Now that's great. So we've got this stuff, but we're not really surfacing it at all. And that's basically the point of my blah blah for the last however long. So what we're going to do is we're going to use something called workbox streams. Now workbox streams is an idea based off of JavaScript streams where you can combine multiple different data sources and then stream them back to the front end. Okay, which is really nice, and it's used for multi-page applications to composite the page of multiple different bits and pieces so you can cache some stuff. So to be clear, I'm using this for something it wasn't designed for. But we're going to go with it and see where we end up. Okay. So if we look at the workbox streams, it's going to do the following. The core parts that we care about is fetching all of the copied local memes and fetching all of the cached memes out of our cache API stuff. Okay? And because this all just gets returned as text, we're going to unroll those and wrap it in angle or square brackets so that it fakes an array. And this isn't very hard, actually. So from here, we can go, I think it was 15. Yeah. We're basically just going to get that array of memes and call the stringify method that I'm going to show you in a moment. And then we're going to here use the existing strategy that we've already created, call it explicitly with an event, read that JSON data, and then return that. And for this to work, what we need is we need this stringify method, which is basically a bit of safety and plumbing code so that this works in case the array is empty, make sure it has the right number of commas, and so on and so forth. So that's just plumbing. Okay? Importantly, we've defined a new strategy, the stream strategy. So I need to scroll all the way up to this root that we registered, and then move it to the bottom before I forget, and then we're going to call the stream strategy. Awesome. Now when we restart this and reload, I hope I'm offline. I am offline. I am online. Application, service worker. Oh, cool. So it's already picked up the stuff that was saved in my local cache from previously. That's awesome. And we've got our server-side replay events. Now, let me just check the network tab. Oopsie. Network tab. Okay, that's right. Check workbox. Workbox isn't syncing anything. So now, if everything goes well, we can go back to this template. We can go offline. Am I offline? Was I offline? Do I have the latest code? Oopsie. Let's just go online. Let's play safe. Okay. Let's play it safe. Okay. Application. Let's go and take a look at the service worker. Make sure it's the right one. It is the right one. It is the right one. Okay. So now I can go offline. I can go and say, do I hear the sound of tempting fate? Yes, you do. We're offline. We're offline. Let's double check because I've lost track now. Yes, we are. We're going to hit save. And then we see a bunch of stuff, right? So the first thing that happens is we see the meme that we've just created surfacing on the UI because I snuck in a little grayscaling thing as a part of the application. Then if we go take a, not print, if we go take a look at the application tab, we will see in IndexedDB that it exists firstly in the IndexedDB queue, and then secondly, we've got both of these offline things stored in here. And what we're now going to do is we're going to, hopefully, if everything works, go online, and we don't see our replay events. Okay. So we're just going to close this down and try again in a new browser window. Okay, let's go. F12. Let's start that again. See, I was tempting fate. Now, because it's incognito, we've got a completely clean browser, so I'm going to have to do that again. Let's go to this, and let's pick an appropriate one. Oh no, it's failing. Then we can go offline. We can save that data. It returns perfectly. And now, hopefully, if Workbox doesn't hate me, I can go online and pick up that sync event. Yes, okay, awesome. So the sync event has replayed. We can see it there at the top. And now if I reload the application twice, because remember that we use stale while revalidate, so we've updated the cache that sits internally, we'll see that our meme gets created. Back on track. But now, ironic applause, yay. Okay, so obviously there's a whole bunch that's wrong with that, right? We had to reload twice to get this latest data. By the way, if you have to reload twice for the conference site, I'm really sorry. And then we're still not cleaning up after ourselves, right? So we can do better than this. So what we're going to do is we're going to clean up after ourselves. So if we go to the bottom here, we're going to use, so not at the bottom, at the background sync part. I've lost my place there. So luckily, this lets us pass in an object that we can configure. Okay? And that object has a list of callbacks on it, and one of the useful callbacks that we're going to leverage off of is queue did replay, so when the whole queue replays. Now, if one of those requests fails, you get unpredictable results, which sucks, and it's something that they're looking at fixing and might make this better going forward. So for the moment, don't keep precious stuff in here. Okay? Keep things that are, if it gets lost, it's not necessarily the end of the world. And I'm happy to discuss specifics afterwards. And then the last thing we're going to do is just clean up after ourselves, which is deleting the memes from our local IndexedDB thing, and then clearing our cache. So we're going to open the cache, we're going to iterate over the keys, find the ones that match memes, and then just delete them. And when we do that, and we go back and reload our application, great. I can go and create a new one, and that new one is going to say, I will stick the demo. And then we're going to go offline. We're going to save it. We see it coming through, and now when we go offline or online again, we're going to see the request replay. Hopefully, if everything has worked, we're going to see that our background sync, that's pre-cache, that our background sync queue is empty, that our key value store is empty, and that our cache storage, that one, data, doesn't have any of the meme stuff in. So when we reload, the application has our stuff saved and already freshed. Okay, that one can make legitimate applause, right? Come on, stop being so tough. Like I stuck it. Okay, cool. So we survived that. I kind of feel that there should have been, because like I got to 19 on the snippets, I really feel like there should have been another one, right? And it should have been something along the lines of, how do I even type? Something like that, I don't know. I feel like it was a missed opportunity. Anyway, but let's go back. All right, so that was rougher than I expected, but we got past the demo. So let's talk about, in summary, right. The browser can do a whole bunch. It's not your grandfather's browser. There are capabilities and features baked into all of the evergreen browsers that the users expect to be able to use. We're not browsing cat pics on Facebook anymore, right? We want to interact. We want the thing to work when it's there for us to work, when we have that need. So just remember that people expect native-like behavior out of web pages, whether you want to or not. And a lot of how we combat this is by being very creative about how we design our applications. We need to be thoughtful and respect the network conditions that they're going to be used under and what that distribution looks like. And then finally, I'm not going to say offline first because it's an awful thing, and it doesn't necessarily cater for every application, but plan for that network failure and figure out what you're going to do when Li-Fi kicks up and office Wi-Fi breaks, right? Or the server goes down, or whatever the case may be, so that people can keep working. So finally, I'm here if you have any questions, and I think we've still got some time for questions, and I hope there are some. I have stress balls to throw out, and I have stickers that I smuggled back from Chrome Dev Summit. And if there's any other things that you care about that are related to PWAs, I've done a whole bunch of talks so far this year, and whether it's some of the UX basics that I covered at the GDG, which some of you were at, or if it's why you should care, or if it's how to do this in Angular, please feel free to go take a look or hit me up. Thank you very much. Anyone? Okay. Sure. That was a panicked moment.
Okay, cool. I just want to know, could you forced a reload when we had to manually reload. Could you have automated that? So when it comes back online, it automatically knows once the replay is done.
Yes. Okay. So go watch this talk. And it will give you some UX patterns. So that talk specifically focuses on the install behavior and prompting the user from the background thread to install. But you can do exactly the same with cache invalidation. And I think there's actually a plugin that you can use that'll prompt the front end to reload when cache gets invalidated. There's two mechanisms. So there's the broadcast channel API that isn't supported in every browser, but there's a polyfill coming from Workbox to be able to do that. And then you can just use service worker post message, which is the same as web worker post messages, and that's very well supported. You don't have to worry about that. I think you've got one of those already, but take another one. Next question.
So you mentioned evergreen browsers.
Yes.
So my question to you is, what about IE?
Okay, that's a very good question, right? So Microsoft themselves want to kill off IE, right? They want you to use Edge, which is an evergreen browser and has good support into it. So IE 11 I think has 3% market share. Older IEs are basically negligible. So if you look at 3% market share internationally on IE 11, you basically have almost treble chance of your users being colorblind than using IE 11. So that doesn't really make sense from a support perspective, if you know. And at the end of the day, like you've just got a website here. Because you're progressively enhancing, the big P in PWA, and I suppose I didn't cover that. If you go take a look at this talk, it'll talk to you about the progressive enhancement bits and pieces. But if we go take a look at our index.html, where we install the service worker, the first thing that we do before we use any of this stuff is we check to see whether it's available, right? Is it in Navigator? Oh. What? Wait, but okay, doesn't really matter. It's okay. You progressively enhance. So you see if service worker is enabled, and if it isn't, you know what? You've still got a good website that's fast, that people can use, just not offline. Do you want to? Okay, keep throwing it backwards. Somebody will catch it behind. Oh, sorry. It was a good catch. Anyone else? Yes. Make the MC run. He deserves it. I expected a lot more trolling, to be honest.
Thank you very much for the presentation. I really learned a lot from it. I'm pretty new to PWAs.
Okay.
So I don't know whether my question is a bit dumb or what, but is there a sort of like a cap to the amount of interaction a user has to have offline with your application? Because with your application, a user is saving memes offline. Is there like a maximum interaction that you have to put on the interaction that the user can do offline, or they can pretty much just go on and on?
Do you mean from a data perspective?
From a data perspective,
okay,
yes.
So that's actually a very good question. So firstly, I had a physics lecturer that told me that there are no such thing as dumb questions, only dumb answers. Okay. And secondly, yes, there is a limit, and yes, it's non-trivial and not consistent across browsers. So it's difficult. There is an API that you can use called window.navigator.estimate. I think it's Navigator, or window.storage.estimate, where they will give you an estimate of how much disk space you have available to use. And some of the more modern thinking is using that I can't show you, using that more proactively about, basically how to engage properly. Chrome DevTools, which I'm sure Simon and Kura are going to show you a little bit later, has the ability on a service worker to show you how much of your allocation you've used and what that breakdown is. Okay. Good catch. Yes.
Hi. So you talked about not loading the whole application on the browser. So how would you curve developers' in terms of not overusing the power of caching the application. So which components are actually special would you categorize for caching, so for customer experience to be
Okay,
better? Yeah.
good. That's a good question. So firstly, I'm going to give you the consultant's answer. It depends. Secondly, I'm actually going to answer the question. So the thinking is that what you want to do is you want to aggressively pre-cache everything that's going to be needed on the first loading of the application. Whether that's the stuff to make your login screen work, whether that's the stuff to just make the app shell of your website work, and then progressively, lazily load everything else. And there's some super cool stuff that's coming for that, and there's some cool stuff that you can do with Webpack to split your bundles up. So firstly, that from a pre-caching perspective, that's the minimum. That's what you need to focus on to make sure that your site is fast and sort of offline capable. From an offline perspective, you need to figure out what is meaningful to your website to be used offline. Because, like I said, having the memes cached offline isn't very meaningful to us. Because yes, it's cool, I can look at my cleverness 25 minutes ago, but I can't do anything with it, right? And I believe that apps should be for using. So it does depend, but there's some stuff around that you need to figure out what that minimum viable thing is offline. Awesome. I'm out of stress balls, but I can take more questions. Yes. Until William pulls me off stage.
Just a question to do with Angular. You spoke about how you use Workbox as your preference. Is there any significant advantage of using Workbox over NGSW for Angular?
Yes, there is. So you should totally take a look at that talk. Okay. That's amazing. I've referenced all three of them. So yes, there is. NGSW, so I can't show you, but if you go back to the Workbox config related stuff that I had, that's about as far as NGSW will get you. It's very hands-off and it gets you a very limited pre-caching stuff and pre-caching stuff only. Okay. If you want to do any more of the advanced, and they are working on it, but if you want to do any more of the advanced stuff, then you need to lean out of it. So Workbox is the spiritual successor of something called SW Precache, which was the first real thing first abstraction layer for this kind of stuff. It's really cool, and Jeff Posnick is a nice guy, so use it. I mean, it's great stuff. And it's just JavaScript at the end of the day anyway, right? So you can use it with anything. Any other questions? Yes.
Hey. I just want to ask, how safe is Workbox to use? So like, with caching and that, you can stuff it up really easily and you don't actually know that the guy's seeing that face palm meme.
Yes.
Yeah.
So, yes, that's important. This isn't a silver bullet that does things makes your application robust for you. You need to apply some thinking. This gives you all of the tools that you need, but you can really hurt yourself. So I had that skip waiting, which is not the right way to go about it. But if you don't think about how your user is going to download updates for your application, then you're stuck with a site that can't necessarily update easily. And users that have to then go and manually clear their cache or wait for Chrome to get tired of your application and clean everything up out of its caches, right? So you can easily get stuff wrong. So it requires some forethought. As for the usage, there's a really awesome Workbox plugin that, if you're using Google Analytics, will use background sync to store all of your Google Analytics events and then replay them when connectivity is available. So if people start hitting those offline scenarios and weird stuff starts happening, you can at least still get some telemetry about it. Okay. Hope that answers the question. At the back. Yes, Fred.
Question. Does Workbox support pre-caching of AJAX requests? Without actually implementing a manual, how do I call it? You basically manually pre-cache AJAX request, but my question is, can you do that with an AJAX request the same way to pre-cache files?
Yes. So it is AJAX. So you remember the fetch event listener that I added and the routing that I added? That stuff is AJAX. Okay, the AJAX stuff just gets piped through the network stack, and the fetch API is what that network stack is called in JavaScript. Okay. I think...
Yeah, we're out of time. Thanks, everyone. Just so you know, the coffee station has moved down next to the pool, so it's not where it was up there.
And if I have stickers if anybody wants stickers. Sticker contraband.